All right. Okay. So I can see we have two people watching on YouTube, and I'm sure more numbers will be joining soon. So good evening, guys. We're going to be talking about software engineering today. Just need to go ahead and just give me a second. Let's see. All right, so I can see the comments. Please drop a message if you can hear me. Just go ahead and drop a message in the chat before we kick off with the session for this evening. Yeah, kindly drop a message in the chat. So I'll be sure you can hear me clearly. All right. Hello. Okay, so that is Joseph. Joseph Buteng, right? Joseph, please can you also tell me where you're joining from? Nigeria, Kenya, or Ghana? Oh, Anita. Hi, Anita. Awesome. All right, so I just informed the moderators on the Discord server to communicate, the link to others. Adeni, Joseph, yeah, welcome. All right, so we're going to be talking about introduction to software engineering. I believe, oh, from Nigeria. All right, so I believe most of already, maybe you don't have any experience of software development, programming, or maybe you are already in the industry. All right, from Nigeria. All right, good. So if you're joining us, if you're just joining us, please go ahead and you know drop a message in the chat. Just say hello and tell us where you're joining from. Okay. All right. So I'll be sharing a link as well with you. So I'm going to share a link. I'm going to share a link to the slide that I'll be using for this session. All right, so just give me a minute. I'm going to share a link right now. Okay. Let's see. All right, I think this is it. All right, so I'm sharing a link to the chat. This is basically the presentation that I'll be using for this session. So, all right, Anita is joining from Mombasa, Kenya. Cassie is joining from Nigeria. Oh, Banjos. All right, welcome. All right, so I just sent in a link, to the chat. I'm sure you can see that link. It's right there on the chat. A tome.app link. The presentation file. So of course you can go to the presentation. Just in case you are unable to see my screen properly for some reasons. We're going to be talking about software engineering. Please go ahead others to join so that you can learn one or two from this session. It's going to be a quick one, right? It's going to be a quick session, and I'll be taking some questions from you as well. So, just in case you have questions, maybe you have prepared some questions, or as I progress through the class, if you have some questions to ask, feel free to throw those questions in the chat. I'll be looking at the chat, and I should be able to take those questions. All right. So I prepared some slides, and I've shared it to the chat. Let me go ahead and share my screen as well. So I'm going to share my entire screen here. And I will just move this to a different browser. Okay, so this makes more sense. Great. All right, and in order for you to also see my screen properly, I'll just, oh, perfect. All right, so Bamjos and Cassie, please let me know if you can see my screen clearly. Is it bold enough? Let's see, can I zoom in on this one? Yeah. All right, so welcome guys. Let's just jump into the session, right? By the way, if you are new to programming, if you're completely new to programming or software engineering, please let us know in the chat as well so we can understand the audience better. All right. If you're new to programming or software engineering, let me know in the chat. I'm currently looking at the chat, so I should be able to, answer or to respond. I mean, depending on your level of proficiency or understanding. right? I will try as much as possible to break it down, which is why I had to share my entire screen so that you can also, I can show some, examples with some diagrams if possible, right? Okay. All right. So I can see the messages. Yes, you can see my screen. Awesome. All right, so we're talking about introduction to software engineering. We're going to try to understand what exactly software engineering is all about. I would start off with introducing myself. So most of you actually know me already, but if you're new in this space, okay. So Adeni said, "All right, I'm a beginner in programming." Awesome. Okay. So yeah, I'll be able to break things down, to make sure you understand some of the concepts or some of the things I would mention. Someone said, "Okay, not new to programming because I'm a CSC undergraduate, but I'm new to software engineering. I just started learning Django." Okay, all right, Joseph, well done. All right, so about myself, I previously worked as a solutions architect, and I currently work as a principal software engineer at Bunker Essentials in Lagos, Nigeria. And I have more than a decade of engineering experience. I've been doing software engineering for a very long time. Yeah, definitely a very long time, very long time. So I think it's over 13 plus years now, and currently pursuing an MBA in advanced AI and the future of automation with Nexford University. So you can actually get to find me. You can check out my website, solomonmarvel.com, my LinkedIn. I'm always active on LinkedIn, as well as yeah, my Twitter account. So you can actually follow me on Twitter, please. Awesome. So let's move on to the next slide. So the next slide I have here is talking about the class objectives, right? I'm going to talk about some foundational knowledge, things you need to understand, the principles, right? When it comes to engineering, the principles of software engineering. We'll talk about structured development. Programming is one thing, some people call it coding, right? Coding is one thing, and software engineering, right, is a different thing because you are working with what we refer to as a development life cycle. We'll talk about that. We'll talk about collaboration, right? When working on projects, right? The collaborative efforts from different stakeholders in the team, right? We'll talk about that and how to go about it, of course. We'll talk about how to prepare yourself, looking at the modern roles, cloud, DevOps, and of course AI. We'll talk about a few things here and there, and we'll also mention QA, right? Quality assurance, and of course quality testing. Of course, when you build products, you have to make sure your software products are properly tested before they get to the user's end. All right. So let's talk about the foundation. So of course, you might be asking yourself, I have heard about programming, I've heard about coding. Where exactly, what exactly is the difference between, software engineering and coding? And yeah, I mean, if you have asked yourself this question several times, I will definitely, answer that question in such a way that I believe you would have a better understanding about this thing. So the first thing there, which is coding or programming, when you hear about the term, coding, we're referring to, simply picking up a language, right? A programming language, understanding how to use this language, and of course, building or writing very basic programs, okay? So when you write a very basic program, like functions, you want to basically perform an operation, like you want to perform a simple operation that can, maybe when I put in A, I want to get B, right? Or when I put in A, I want to get B and C. You are going to write a very simple program to do that. That, of course, is programming, right? That, of course, is coding. And, we're looking at multiple languages here. So when you're trying to build a software or you're trying to write code, you are definitely going to first think about, the languages, right? We call that programming languages, right? Where you mention, we talk about Python, we talk about JavaScript. Maybe you have heard about some of these languages. So you basically pick up a language, you write one or two programs, right? And you execute those programs, it works. That is what you do as a programmer. When you begin to put together so many programs, right, in such a way that you can then package the program, when you package that program, it means you have a program that can do A, B, and C, or you have a program that works this way, and then you are able to package that program and deliver that program to someone, right, the customer, All right. And when I mean customer, it can actually be like a huge organization. It can be a single client. It doesn't matter. The major thing is there's a process here. I wrote the code. I packaged the code, right? Whether I am deploying it on the web to run as a website or a web app, or I am deploying it as a standalone, desktop application, right? For those of you who install Microsoft Office, for example, that's a desktop application you install, okay? Or maybe you're packaging this as a mobile application. So we're still talking about the same thing. If it's a mobile app, if it's a web app, if it's a desktop app, if it's an app that runs in your car, a software that runs on your car's dashboard, right? We're still referring to software engineering. The major thing you need to understand is we have different, type of, software products, right? We have some software products that run inside other devices, right? Embedded software. We have software products that run on your mobile, right? We have the ones that run on your, locally on your laptop. You have to install it, and we have the ones that run on the web. All right. We even have software that run on, your regular home appliances. I mean, we're still referring to software engineering because there's a process, right? There's an engineering process. There are principles you have to follow, to deliver this software from the factory. And when I say factory, I'm referring to the place of development, right? Which is, of course, the place you develop the software with other teams, right? So there's a process that follow this software development, this software development, from the point where it's been built down to the customers, right, before it gets to the customer's end. So you need to understand, some of those things. Okay, so let's talk about, let's talk about when we talk about software development, as I mentioned earlier, right, it's different from programming. So it's of course beyond just coding and those algorithms, right? So it actually covers a lot of things. And if you look at the slide, I wrote a bunch of things here that I believe would explain this even better if you decide to delve into these topics individually, right? So we mentioned designing, right, developing and maintaining software, right? Designing, developing and maintaining software. Now, when I say designing, most people might assume that I'm referring to just the designs, right? The Figma designs, the UI. We refer to some of those things as user interface. Yeah, of course, user interface. But it actually goes beyond that, right? It's not just we're not talking about the user interface only. All right, we're also talking about the design in your code. I remember having a session where I was explaining to someone that it's actually a good thing for you to learn how to design, your code efficiently, right? So you design your code in such a way that when you have new software developers, when you have new people join your company, they're able to look at this software and they understand that, okay, this is the pattern, right? This is the pattern that we have to follow. If you have been into software development for like a year, right? Maybe you might have heard of what we call design patterns. And of course, it's not necessarily something you should talk about, if you're a newbie, if you're just starting out. But over time, you would get across, you come across that, and you would see, more. You would get to see the relevance of actually designing your code, properly. Okay, and yeah, so of course, designing, developing, right, developing your code. So let's work with an assumption here. I love working with scenarios, right, because it actually makes you, think about this explanation better. Okay, so let's say we are met with a case study. Someone actually comes to us and say, Joseph, I want you to build a simple software that can send a message every morning, right? Every maybe 8 a.m. I want to send out a message, right? So I would have to put in my message, and the software has to do the job of sending out that message, right? So let's just try to understand what I mean by design and development, right? So the first thing you would ask yourself is, okay, as a software developer or someone who eventually becomes a software engineer, um, what is the first thing I want to do, right? That's the first question that comes to your mind. Okay, how do I start? How do I start building this? If you are not the kind of person that thinks about the process, right? As an engineer, if you don't think about the process, the first thing that comes to your mind is let's just start writing code, right? Let's just start writing code. But of course, as you might have guessed, this is completely, wrong. You don't do this. The first thing you want to do is, gathering what we call requirements, right? So software requirements. So as I mentioned earlier, the process. So you want to first start by gathering the software requirements. You want to ask questions, right? Software requirement is all about asking questions, and this is a big problem that so many developers don't even understand yet, right? Asking questions, because if you have more details or more understanding on what a software should do, then it's easier for you to at least create a roadmap around that and work towards achieving that. Okay, so from the example I gave, someone is giving you a requirement. We want to build a software. The software should be able to send out a message 8 a.m. Every morning, right? Or maybe the person just said by 8 a.m. The first question you should ask is, okay, first of all, the software, the only requirement we're looking at is sending a message, right? So sending a message, and the person said at 8 a.m. Okay, so let's say by 8 a.m. Okay, so we have 8 a.m. And now this is the point where you begin to ask, when you say sending a message by this specific time, is it every day, right? Is it something we should do once in a week, right? Is it something we should do? Should we also include weekends? You are asking these questions because you want to be very sure. And what kind of message are you looking at, right? So, what kind of message? Who are we sending these messages to, right? First of all, when you ask what type of message, is it an email? Is it an SMS? You need to ask this question so you can at least put on paper, right, or maybe on a note somewhere. You need to understand what exactly comes in and what goes out. Okay. So, what kind of message are we looking at? Is it SMS, right? Is it email? This is part of your requirement. You have not started designing this just yet, but this is going to basically help you out when you are ready to design the software. Okay. And when I mean design, I am still not referring to Figma. So let's not talk about like UI designs for now. So when I mean design, I'm talking about how you would design the several code functions and methods that you're going to create. Okay. We'll talk about that as well in the future. Then you are asking, who are we designing the software for, right? Who is the ideal user? Because if you don't know the ideal user, then it might also be a problem, right? Because you want to be sure if the ideal user would probably prefer SMS or email. So at the end of the day, when you make a decision to go with email, you are rest assured that the user should be able to also send out the emails. Okay, and of course we already know the what, right? So we already know the what. Let's see. So and now you're basically, so first of all, we already know part of the what here. I need this has to be a part of this. Okay. All right. So just correct. Okay. So we already know that we are sending this, right? We're sending a message. We already know the time, but now we've asked some questions. We at least understand the channel, right? And next we also understand who we are sending these messages to. So this makes sense. And of course, you can proceed to ask even more questions, right? To get more details about about what we're trying to do, right? So we'll call that requirement gathering. And then when you're done with that, before we get to some other stages that we'll touch on, very soon, right? But at the end of the day, the idea of engineering, software engineering, is to be able to design, develop, and maintain. So we've said nothing about maintenance just yet, because I have a section where I would actually dive into that to explain more, right? But just to give you a very fundamental, knowledge, maintaining the software is basically talking about the ability to keep a software running for a very long time, right? And of course make necessary changes or upgrade. Things change, right? Things are changing rapidly. So if you build a specific software this month, let's say in 3 years time, most of those things might not be supported anymore, right? And you want to make sure, you want to upgrade those code base, the language, or I mean, it depends on what you're upgrading. But that process is part of the maintenance, because if you use some technologies that is quite difficult to find an alternative to, then of course it becomes a problem, right? It becomes a problem, and that is basically what we refer to as bottlenecks. That's the buzzword you'll find most people use. So it becomes a problem, and you have to understand some of these things, right? You have to understand the engineering process, so you don't make too many mistakes, right? You can never be 100%, perfect when it comes to planning and gathering requirements. But when you follow these processes, of course, it would lead to making fewer mistakes or having fewer bottlenecks as you proceed in your software development process. All right. So why programming is essential is an essential skill, of course. Software engineering adds a layer of discipline and organization to ensure that software is reliable, scalable, and maintainable over time. Reliable in the sense that the software would actually run without waking up one day to see that your software is down or it has been down for a very long time and customers have not been able to use this. You actually build software that is reliable. When you understand the principles of software engineering, the software will be scalable, right? Which means you can decide to even expand that software to meet more audience, right? You build a software today for just 10 people, and in the next 1 month, these same people tell you, okay, we have 100 new customers and we want 100 customers to use it, right? The next month you hear we have 1,000 customers, we have 2,000 customers. So applying the software engineering principles would, it would aid you build software that can actually scale, right, over time. All right. Now let's talk about some of those principles and some of those. Let's start off with the life cycle, right? When you're building a software, what exactly is the software development life cycle? So this is something you would find, most times when you try to ask the question, what is software engineering on the internet, right? When you Google this, you would probably come across, SDLC, all right? And software development lifecycle is simply giving you this roadmap, right, that would guide you on the entire process of building a successful, okay, I won't use the word successful. I think I would just say building a software, right? Yeah, so we don't get confused with the term successful there. So I would simply say guide you through building a software. The roadmap would basically so when you look at the SDLC roadmap, it's basically talking about the starting point, which is the requirement gathering, which is what I've mentioned earlier, right? Then when you gather these requirements, so it says, okay, where we gather and analyze users needs, of course, and then you come down to design, where we architect the software's structure and functionality. So this is basically what I'm talking about. It's not about designing the interface. It's about making some decisions, right, as regards to how the software would operate, especially on the code base, right? How the code base would be structured, how data would move from one part to another part, right? So you're basically designing that part, designing that that specific flow, right? Data flow, connection flow. You're basically going to think about these things and draw out some plan. I mean, if you don't have a plan, you're just going to be, very random at, making decisions, and that is not a good thing, right? You have to make sure you have a plan on ground. Okay, and what else do we have here? So yeah. So basically, after the design phase, we'll talk about implementation phase, right? And this is where you basically start coding. You've designed already, so you start coding and writing the code. Of course, following your initial design. Now, the thing you must understand is, customers can always change requirements. You can actually start building a software, and after a while, the customer comes in to say, "This is not, what I want. We have to change the requirements." And we'll get to talk about agile very soon because that is where agile comes in. We'll talk about that. But at the end, this is basically a fundamental roadmap that you have to follow because, of course, you should gather the requirements. You should design, at least with the initial brief you receive from the client, you should design something, right? Whether you are designing on paper, you are designing on your laptop, or you're even designing in your head. But I would advise always design on paper or your laptop. Have what we call a clear documentation. We'll talk about that shortly as well. All right. So you have designed it, you are implementing, you have the programmers or the team of programmers doing their job, right? Building this. And after this phase, after the code has been written, the next thing you want to do is, of course, to test the code, right? You pass through. The developers can, of course, test this from their end, but you also want to make sure that you have a team of testers. Except you are a very small team, then of course you can even do this test yourself. But at least test to some reasonable extent. Test the major functionalities. Make sure that your code works, right? Make sure that the project delivers. Make sure that the project meets the user, requirements. Okay, and when you test, you of course identify and fix bugs, because the idea of testing your program is that you would probably find some bugs. Okay, so yeah, I mean, debugging is a different thing, of course, but I'll just give you like a simple, meaning to that term. When we say we are debugging, you are basically trying to fix some errors that you detected, after, probably while testing your code. I think that would be the best way to describe this, right? So you wrote the code, all right, and you are testing now to see that it does not, do exactly what you expect it to do. All right. So there are some errors. Now, when it comes to debugging, there are different, levels and different types of, errors. Some errors that I will just give you like, the high level, right? So we have semantic errors and syntactic error, right? So syntactic error is when you have errors with the code base, right? Maybe it's not compiling because something is wrong. The compiler or the programming language does not understand what you're trying to ask it to do. That is, a syntax error. When we talk about semantic error, it means it actually compiles, it runs, but unfortunately, the result, the meaning, right, is not what you expect. All right. So that is what you must understand those difference. So it runs, but the meaning or the output is not exactly what you expect. So that is semantic error, right? An error that has to do with the output or the meaning that the program is trying to give you as a result. Okay, or that the software is trying to give you as a result. So yeah, try to understand that. That is for bug fixing, right, or fixing bugs. Okay. All right. So yeah, when you're done with testing, then you move on to the final stage, which is deployment and maintenance. Okay, this is broken down here. So deployment is the first thing you have to deploy to the users. And as I said earlier, I mean deployment depends on how your users want to access or yeah how they basically want to access the software. So I remember this should be in 2014, right? 20, let's say 2020, between 2012 to 2014. And I'm actually thinking it's 2012. I can't remember, but that was when I deployed and I packaged, a software on .NET for the first time, with C Sharp. And yes, so I basically packaged that software. It was a result computation software. I was in school. Yeah, it was a result computation software for my school, and yeah, so I actually learned something in that period because I was a huge fan of desktop, development. I enjoyed building desktop application, using VB.NET. I started off with VB, right? I started off with VB scripts actually, then moved into VB, and then VB.NET. Then of course, VB means Visual Basic, by the way. Yeah, so of course I used some other, like basic. Writing .bat files, basically writing some scripts. Yeah, and I later, enjoyed using Visual Basic.NET before using C Sharp. So within this period, I've actually built a lot of programs. I was testing and playing around with them until, yeah, okay, until I started building software with C Sharp. And there was a period that I was tasked with, all right, this is good, compile this, package it into a software, make it installable, and let's ship it off to to the customers. And I remember the first thing that came to my mind was, okay, yes, I've been playing around with these things, showing people on my laptop. Now it's time to package it. How do I even go about it? Right? I was panicking. But yeah, I mean, I spent a couple of days. I was able to, learn how to really package and build a MSI. We call it MSI bundles. When you package it using, I think it was called an MSI bundler. I cannot remember the name, but yeah, I was able to package it to that tool. I think it's not get bundler something. I can't recall the exact name. Packaged it to that tool, delivered it, and when I delivered that software, of course, I tested it, but I only had two laptops, right? My laptop and a friend's laptop. So I was only able to test it on both systems, but I knew very well that when I installed this on a different laptop with a different architecture on when it comes to the operating system, it might not work, right? And of course, it did not work because the customer then I remember it was using a machine that was running on 32 bits, right? For those of you that understand, the operating system jargons, it's 32 and 64 bits. So this same software did not work. I could not even install it, right? The installation did not even start. Are you expecting the customer to format or basically delete their operating system and install an operating system that works for your software? I mean, it doesn't work that way, right? It's not practical. So I had to go back and learn how to bundle a software that can run on multiple architectures, and eventually even learned how to deploy softwares that would run on cross-platform systems. This is basically what you learn when you start doing the work, right? It's basically what you learn because you discover that the way I use this and the way I bundle my software is probably not the way the customers would expect. So if you do a very detailed requirement gathering, you would ask them, how do you want to use this software? Is it going to be on a mobile? Is it going to be on a web? You want to access it via a URL, or you want to access it as a desktop application, right? And trust me, you might be telling yourself that no, everything is moving to the web. You need to understand that there are some customers or a specific type of customer base that might not even remember the URL, except they have to employ someone to do the job for them, an admin, which is what most companies do, or most organizations do actually. I once built a software for a cooperative. We'll call it, of course, you know what a cooperative society would be, and it was for a school, a polytechnic, for some of the lecturers, right? Mostly the elders and the senior lecturers in the school, and they could not even remember, the URL where we hosted the software. We had to rebuild that software, and we packaged it as a desktop application, a native Windows application, right? And they used the software for a long time until they rotated their board and they have a new admin who is also, a matured person, right? Probably in his 50s. Yeah, in his late 50s. But this time around, the new person was using a MacBook, right? And when we try to explain, we're trying to explain that, oh, this software actually just runs on a Windows, it doesn't run on a MacBook. And we're explaining to a team, a board, and they were asking us why, right? I mean, what do you mean by? I mean, we paid you for a software. What do you mean by it doesn't work on a MacBook? Also, you mean I should get a new laptop to run a software I paid you for? So you begin to understand at that point that the client gave you a requirement, but you did not do proper, questions. You did not ask questions, because if you asked questions and you took these things down, documented it, and then the client approved it, at least you have something to fall back on and say, okay, you asked us to build this for a Windows machine, right? Because you could not use it on the web. All right. But now we only said, well, we're building something native, which means the client is right when they say we should, deliver that software on his MacBook. All right, and we have to go back, to work on that. So these are things you should know. These are just, simple scenarios, based on my own experience, and I hope you learn from that. So speaking about some of the key concepts of software engineering, we have a lot of concepts, right? But these are some of the, vital ones that I believe you should know if you're just starting out: abstraction, modularity, reusability, and scalability. All right. So let's start with abstraction. Okay, so the meaning of abstraction, what you're doing is you're basically simplifying, a complex idea, or complex systems, by focusing on the essential features. So, as a software engineer, someone tells you, we are trying to build a software that should be able to do, we're trying to build a software we're trying to build WhatsApp, right? Let's just use that as an example. We're not going to do any system design, so we're trying to build WhatsApp. And then the first question you would ask yourself as someone who is trying to get into software engineering is, what are the core features when you try to look at this from an abstraction level? Okay, what does WhatsApp do, right? And you begin to break things down, right? Send message, right? Send message is a feature. It would have different, ways of configuring this feature, or even breaking it down, because you are now going to ask yourself, what exactly are we sending? When you say you are sending a message, what kind of message exactly? So you can send a photo, right? Of course, you can send a video, right? You can even send, text. Okay. Yeah, and of course that's a feature. And you are now looking at maybe upload status, right? Or let's just call it, let's just say status, right? And when you look at status, you are looking at, of course, uploading a status, deleting a status. You are basically setting up abstractions because remember, you can also delete messages, right? So here we look at messages, and you can send messages, you can delete, right? You can delete either of these options. You should be able to break this down in such a way that you understand this from a feature level before you even start your implementation. So what we're looking at right now is the abstraction. All right. So you can delete. What else? What else can you do? Think about it. So you can, of course, you can, set up your profile. So we have profiles. We have your customization. There's so many other things. So let's just look at it from this angle. So uploading your status, deleting your status. I mean, what else can you do with the status? So if you think about this, you go through the mobile app, you are definitely going to learn a lot of things, and you begin to figure out that, okay, these are the major functionalities. There are so many things to look into when it comes to each and every one of these, feature. But you are, at least you understand what the feature is meant to do, right? You understand what that specific, software or application is meant to do, right? Instead of just thinking about it, we're building WhatsApp, we're trying to build a communication platform. What exactly, someone says we want to be able to send messages. What kind of messages exactly? You want to be able to send a photo. Okay, when you're sending a photo, is there any specific format, right? Do we have like a specific size in mind? Let's say, should we only send photos that are about 5 megabytes? You're able to break this down, and after breaking it down, you can then jump into, like writing your code and really specifying these features, right? In a code base, right? You're able to specify this in a code base. And we don't have enough time, so I won't even try to do that. Okay, so we don't have enough time, but I hope you understand the message here. So that is what we mean by abstraction, right? You simplify those complex systems, you break them down, and you focus on the essential features that should, give you, at least a functional software. All right. Now, modularity. So the idea of modularity, encourages you to break down, the software into smaller and manageable components, right? So let's go back to what I was showing you here. So first of all, you're able to bring out the features from the abstraction, right? Messages, right? That covers a lot of things. So messages covers a lot of things, right? Like, sending a photo, sending a document, sending a video, sending text. So everything falls under messages. So the first thing is the abstraction, which is pointing out the major features, right? Messages, status. Next thing is modularity. All right, so let's separate this, right? So modularity, you tell yourself, okay, it's time for us to actually separate this. We have message, we have status. Let's build this differently, and let's try to set up some sort of connection. How does this relate to this, right? How do you know the owner of a message and the owner of a status? Now, this is the point where you now have a profile, right? So a profile, and if I use a diagram here, it's basically showing something like this. You have a user, right, which you can also, say is a profile with, of course, the name, the user status, their current, status, and a bunch of other details. But let's just say a user then has, messages, right? Whether sent or received messages, there should be a way to trace that message to a user, right? So, and then you have status, okay? So this basically, this stuff is basically connected. And let's go about, connecting this just like this. So this guy is basically connected to A and B, right? So a specific message can be traced to a user, whether the user sent the message or received the message, right? There should be a way to trace to the user in such a way that even if the user should delete their account and create, that same account again on the phone, they should be able to see that message, right? Because it's tied to the user. Same goes for the status, all right? And of course, a bunch of other connections. Now, when you are able to build this in isolation or build this separately, this is basically different modules, and you have modularized your system. You can go further to modularize a status or a message, where you can now have different, types of messages, right? We mentioned that, like sending photo, sending, what was that? Document, right? And of course, sending videos, right? And I'm sure we even have more. We even have sending contacts. But let's just connect these. Let's take this off. So now you have other sub, I would call that modules, right? Sub modules. So you have a new, modularized layer here. Okay, so by the time we build this individually, I built a feature to send a video. It works. Awesome. I have built a feature to test the model, to send the model, to send a photo, and they all fall under messages because whether you are sending a document, a video, or a photo, you are still sending a message, right? So the structure, the way you structure software is very important. And if you understand the idea of modularization, right, you are able to break things down in such a way that it will not confuse anybody looking into your software, or if it will not even confuse you coming back to this software. All right. Okay. Then we also have the idea of reusability, and this actually emphasize more on creating a code that can be used in multiple contexts, right? So what do we mean by multiple contexts here? Let us imagine that we're trying to write a simple code to send um, our email. We mentioned that earlier. So we're writing a code to send our email, and you basically have what you call uh, let's call this email sender. All right. So this is kind of like a code base, right? A function. We're describing this with an image here. So you have email sender. Let's say this is built, with Python. And when you're trying to send emails, you are always asked what exactly do you need to send this email? What are the requirements? What are the kind of data, the inputs that you need? And then you are saying, okay, so when we're about to send an email, at least we need to know, who is sending this email, which is from, who we are sending this email to, which is to, and then the subject. All right. What else? What else are we looking at? We're looking at the message. Let's call that the body of the email. Right. What else are we looking at? When you look at this example, what else would you be looking out for if you want to send an email? So let's keep it at this right now for now, okay? From to subject and body. Maybe you want to add like some CC, when you are trying to copy or send to others. But let's just keep it simple. You started working on this on a project, and you have this function that can do this. And then your manager comes in one day and he says, "All right, this time around, we really want to send this, stuff, but we also want to include the name of the customer so that when the body of the email will not just look like hi customer, um, how are you doing? Okay, so let's just say we have hi customer, and this is not a good way to write this. Let's do this outside. So first of all, this is what you are expecting to send in. This is the body of your message. This is the from. So let's say we're sending this from room at bettercopper.com. We're sending this to let's say Marv at maybe solomonmarvel.com, and this is the body of the message, and of course the subject, right? The subject of the message is hello customer. Okay, so great. This is exactly what it looks like here. But the new boss comes in and say, okay, this time around we actually want to send an email, and when we are writing the body, we actually want to say hello Marv. Okay, so we want to tag Marv, right? The question you are now asking yourself is, we want to send this email to 500 customers at the same time, which means we're not doing it one at a time, right? Which means this Marv you're seeing here has to be passed in as well, right? As a template, we'll call it a template, but this Marv has to be passed in. Now, how do we pass in Marv when we only have from, to, subject, and body, right? This is, rigid. There's no level of, dynamism here, right? So this is the point where you begin to think about reusability. You begin to think about writing code that is reusable. And one thing you might want to do, and this is optional, but you might now decide to say, okay, I also need a template, right? And the template, in this case would be an object, right? So an object is, you can basically pass in something similar to this. So when you're working with an object, you're looking at the possibility of saying that even though I want to send this email to one person or to so many people, I also want a way to accept something, an extra data if it's necessary, right? If it's needed. And our template can carry, like some extra data like first name, whatever it is, last name, etc. So you can basically carry different types of data. Now, when you write something like this, knowing very well that I can pass in the template, or you can even use just the template and pass in everything into the template as an object. It's easier and to reuse because it's not you are not locked into just accepting these four string items, right? When I mean string, I mean something you type like this, a regular text like this, okay? So that is what I mean by string. All right, so I hope you understand that. By the way, if you have questions, feel free to drop your questions in the chat. Let's move on. So scalability ensures that software can handle increased demand without sacrificing performance. And I explained this earlier. The ability for your software to be able to scale to meet more numbers, right? Without sacrificing performance, which means without your software lagging, right? Or without your software, failing at times. You want to be sure that the software does its job 100% well, right? While it is able to scale to meet new users. So if we have 1 million signups, the software still works. You have 2 million signups, the software still works. You have 100 million signups, the software still does its job. All right, and let's talk about some methodologies. So some methodologies used in approaching software development. First of all, you see that we don't have a single style or a single methodology that works all the time. But a very popular option that works very well is, agile, right? So the waterfall model or methodology is a linear approach, and this is basically suitable for projects with well-defined requirements because with the structure of the waterfall model, you basically go in a linear form. When you get to a stage, if there are changes in the first or second stage, it is very difficult to go back and fix those go back and fix those changes, right? Of course, it's possible, but it's very difficult because everything is moving in a linear fashion. Now, when it comes to agile, it actually emphasizes more on flexibility and iterative development, which means we might have gotten to this stage, but if something comes up, we can easily go back, fix it, come back to where we left off, and continue from there. Okay, so most companies will definitely embrace agile. I mean, it's an industry standard, and we of course advise a lot of companies to embrace agile. And under the agile methodology, we also have Scrum and Kanban. Most companies would always go with Scrum, right? But I don't think, I think the moment you actually adopt an agile practice, that is what matters the most. The fact that, we're basically looking at the flexibility of the development process, right? That is the most important thing. And of course, it allows the teams to adapt to changing needs and priorities, okay? All right, and let's talk about collaboration. So if we have questions, please drop your questions in the chat. We just have 10 more minutes to go. So by the time I'm done with the slides, I can also take your questions, okay? So looking at version control and collaboration, I'll give an example here. When I started software development, I personally did not know about version control, Git. And of course, I don't think, let's see, I want to be very sure if GitHub was, already a thing. I can't remember. So I would say, when was GitHub founded? Oh, yeah. So I think it was already a thing, but I was not used to, work. I probably have never heard of the term version control because I remember I became, I started, doing more of writing some of these programs with VB and VB.NET. This was like 20, maybe 2010, 29, 2010, right? Yeah, 29, 2010. I was already coding before then, but at least I started understanding that I was even coding. The first program I wrote, I remember clearly, it was right inside Microsoft Office 2003. So they have this ability for you to write macros, right? So you basically double click on a macro, you can drag in like a button into the text editor, and then when you double click on that button, it takes you into the macro environment, which is in VB6, and you can then write, some basic code. So I saw something, I copied, pasted around, and when you click on the button, it shows you a message, right? A very simple pop-up. It was fun, right? And I did not really know I was programming until I started learning how to build simple websites, from my brother. And funny enough, my brother did not even know he was programming, right? So we're just playing around. No, VB is not VS Code. So VB is a language, right? VB is actually a programming language back then. Visual, let's just say VB6. Let's just go to VB6. Okay, I set up with VB6. So this is VB6, right? It's a programming language. And as you can see, it was first released in 1991. Yeah, it's a Visual Basic developed by Microsoft. And this was the environment. I remember the picture very well, the environment where we write code. So this is what it actually looked like, right? So this is what it actually looked like. I mean, it was fun, right? It was actually fun. This is okay. This is not. Oh yeah, this is clear. So this is what it was. This is what it looked like, and this then migrated into like the .NET ecosystem. Where we now have VB.NET, right? A more interactive and friendly environment for programming. But yeah, basically this is what it actually looked like back then. When you are writing code, you create your form, you drag and drop your buttons, and then you write the code inside some of those things. So yeah, I mean it was a programming, yeah, it was a programming um, environment, right? A programming language with a GUI environment. So yeah, I mean, so back then, I remember writing a simple script, and I wanted to share that script with a friend of mine. I was in secondary school. This was way before 2009. We were writing what we call bat scripts. So let's go back and search for the bat files. Okay. So let's just search for an image environment of what it looks like. So these are bat scripts, right? So we're writing some of these fun scripts, where you can simply run this and it says something or it does something, right? And I wrote some of these files and I wanted to share, I wanted to share this file with my friend. I think I was in senior secondary level 3. So yeah, SS3, SS2, I think SS2, I guess. So I wrote something and I wanted to share with my friend. I had to, put this in a floppy disk. Yes, I put this in a floppy disk, and I had to take the disk down to his mom's shop. His mom's shop. They had this computer center where they do typing and printing of documents. So yeah, back then. So I had to take this myself, and I was explaining what I did. It was when I do this, it runs. I mean, to me, this was automation, right? So automation to me back then. So of course, we all use Windows. Most of us, back then, we were always using Windows XP. I used Windows 98. I loved it. Yeah, because yeah, we just wanted to play around. So I write this scripts and I take these scripts, in the floppy drive, to my friend, right? And we'll run it on his own computer. You run the command as a .exe executable, and it runs, and we're happy, right? So, but the thing is, when it comes to editing that code, it is something I was doing, at home, and then I would take the floppy disk I will save it in the floppy disk and take that floppy disk down to his place, which was not very good, right? It was not very efficient, but that was it was a big deal back then because of course we're actually showing off our floppy disks, the most pretty floppy disk. If you don't know what a floppy disk is, or maybe you have not seen it before, it's kind of like the older version of what you have right now, your flash drive or saving in the cloud. So we basically save items into the floppy disks. The popular ones were the black colors, in my area. So whenever we get or lay our hands on the colored ones, we brag with it, right? So I have a green floppy disk. Okay, I have a blue floppy disk. I think this was sold. I can't even remember the exact price, but it was fun, right, back then. And that's how we basically transfer, files from one, person to the other person. But eventually, we now have what we call GitHub and Git. So you can basically work on your code. You have what we call version control. You can basically set, basically commit. We call it commit. You commit different, versions of your code base. It shows off different history, right? And over time, you can then decide to push that code you have locally on your laptop to a platform called GitHub. And we have different platforms. GitHub is not the only one. We have Bitbucket. We have what is this popular one called? Forgetting the name. So we have GitHub. Let's see versus GitLab. Yeah. So we have GitLab, very popular. We have Bitbucket. But GitHub is the most popular option out there. So you can basically push this to GitHub, add your friends, using their email, and then you have them, work on the same file or the same project, simultaneously, right? So yeah, I mean, when you talk about software development, it's something you should know how to use because you're going to be collaborating with others, a lot. So collaboration is very important. All right. So you learn how to use Git or any other, version control solution out there You also learn how to work with, tools like GitHub or GitLab or Bitbucket, so that you can, be very good with, collaborating with others. Okay, yeah, with collaborating with others. Software development these days is, it's a big, endeavor. So you want to be very flexible, right? You cannot build a massive software alone. I mean, you can, but most times you'll find yourself building with other people. So you want to make sure that collaboration is seamless, right? And that is where, collaboration with GitHub comes. Now, talking about quality assurance and testing. I said it earlier, this is very important because, ensuring software. So right now, the thing you must understand is you can work on a software that works on a machine, but it probably would not work on a different machine. Okay, so you want to make sure you have extensive testing. We have different types of testing. Testing is a different, world on its own, where you basically have to, understand, like, what are we testing for, what kind of test are we meant to do at this stage, at this point, right? So the idea is you are basically going to make sure you have tried, or examined the software you built and its various components to make sure it works and it meets, the user expectation. We have different types of testing, right? So unit testing is when you test the individual component on your code before you push it to the user. I'm testing those components inside the code, right? What I have worked on to make sure everything works and I did not break anything. Okay. Integration testing is when you test the interaction between the components, right? A particular component is now communicating with a different component. Does it work? Right? After a month, is it still working? Because we just made some changes. Does it work? All right. Now, functional testing is when you basically test the software against the direct specifications. What they should do as a software, what the software should do. Right? This software is meant to send an email. When I test this on the unit testing angle inside my code, it works. Right? Functional testing is when all the components have been, put together, and we're basically testing to see that I put in a particular email, it sends, right? Maybe from a user interface or something. You are testing the functionality of the software, right? We have acceptance testing, which is, how you ensure that the software meets the user expectation. So now the software is sending the email. Is it sending the email the right way? Are we able to send the email if the email does not contain this data or that data, right? Does it meet the user expectation? That is acceptance testing. We also have more, we have more. We have what we call smoke testing. Let's not talk about that. That is more detailed, and you need to understand that software testing is actually a big, it's a big deal. And you want to be able to test properly so that you don't get to the point where, you begin to tell your customer or the client that it works on my end, it doesn't work on your end. That's your problem. You don't, that is not accepted. Okay, you don't do that. Okay, documentation. I said we're going to talk about this. Documenting software is very important, right? So documenting software is like having a trail of breadcrumbs for future developers, right? And the comprehensive documentation includes having a user manual, having technical specifications, having well-placed code comments, so that when someone look at your code, they don't need to try to, crack their brains to remember or to understand what the code should do. You have written a clearly defined comment that when they look at the comments, they understand this. They understand that this code is meant to do A or is meant to do B, right? And this will definitely help them, troubleshoot the software if there's an issue or there is need for changes, right? So you should be able to write good documentation inside the software and even outside the software in form of a detailed manual that someone can look through. I'm going to show you an example. I'll show you an example of this because it's very important. Most developers feel that or most developers don't even document code properly. So I have a project I usually use as an example here. So forget about the things you're seeing on my screen. I'm just going to dive into a specific project that I have here. Just to show you, let me open it up in a different environment so this does not look awkward. All right, so let me quickly, just give me a moment. I have, right here. Okay, good. Okay, so I am going to show you this example. All right. So this is a very simple example. This is a software project, right? For it has different modules, but I'm going to show you one particular module, which is the wallets, right? So let's just jump into wallets. So if you look through this, you see we have payment, we have blah blah blah. This is wallet. So let's check this out and let's look at what a documentation look like. So just take a look at this. This is comments, right? This is you writing comment to tell the user what each endpoint should do, right? So this is for preference. This is, let's go down to the route here, or the route. So you see, we're actually creating a wallet with this code. We're expecting a user ID, initial balance, the currency. You're able to state those details there, right? When any developer looks at this, they understand what this is meant to do, right? When they look at this, they understand what this is meant to do. And as you can see, we have multiple files, and each of the functions or methods are properly, they have proper documentation, right? So that's what we mean by documentation. Forget about the code base itself. A programming language is something you would eventually get to learn. It must not be JavaScript. It can be TypeScript. It can be Python. It can be Rust. It can be Go. It doesn't matter. The major thing is, you believe that you can use it. You have learned how to use it. You're proficient with that language. You know what you can create with that language, and the rest is just possibilities, right? Based on your mindset and your imagination, what you can create. Okay, so you are definitely going to find yourself doing stuff like that. Um, yeah, yeah. And also, you should also understand that, in software engineering, you must not write code, okay? You can actually be on the team where you test code. You can be on the team where you basically write documentation. Probably that's what you do. I mean, it's a big deal. You can have a very massive code base. If you don't have a good documentation, nobody would want to use it, right? Because nobody wants to come in there to spend the next 1 year, just trying to figure out what people have been doing for over 10 years. All right. So they would prefer to go with a smaller code base that does the job and has proper documentation. All right. So documentation is something you have to learn to do. And yeah, so I mean that is it. Looking at some of the future trends, you might have heard of AI, blockchain, DevOps, cloud, serverless. There's so many things out there that will basically be like I would say an addition to what you learn. You cannot know everything and you cannot learn everything. So try as much as possible to learn what you need. If you're looking for a job, learn what you need for that job, right? If you're talking about software engineering and you're looking for a job as a front-end developer, you probably want to learn JavaScript because you definitely would need JavaScript. It's very handy and it's something you would need as a web developer. Learn how to apply these engineering principles into web development, right? If you're trying to work on hardware components, IoT, Internet of Things, working on machines, right? Creating machines for specific use cases. You probably want to learn, C or C++. You want to learn how to use Arduino, right? Those kind of gadgets. You want to learn how to use Raspberry Pi with Python. So I mean, it depends, right? The major thing is that software engineering would remain software engineering. The engineering process, you are able to apply those engineering principles, documentation, testing, your requirement gathering from the beginning, the development process, you are able to plan these things, at least, using the agile methodology as well. You're able to apply a methodology to guide your process. All right. That is the engineering we're talking about. So, yeah, yeah. So yeah, that is it. So you are able to apply these, engineering principles, and of course, so that is it. And this is basically, the foundations, right? You understand what software engineering is and how you go about it. The next thing would be, okay, I want to be a backend software developer or a software engineer. I want to be a front end software engineer. I want to be a mobile engineer. I want to be, a cloud engineer, a DevOps engineer. So at the end of the day, everything still falls under software, right? You're still building software. You're still in that process of building and packaging software for some users. So you have to learn to, follow those principles. And yeah, have a functional software at the end of the day. Collaboration, remember, very important, right? So you have this slide, and I'm sure you can basically go through this slide once again. This session was not for showing any practical, like example, but I was able to show some diagrams, and I believe you learned something from this. If you have any questions, go ahead and drop the questions in the chat. Let's take questions for the next 5 minutes or less. All right, and yeah, please also remember, I think there's a feedback from somewhere that will be shared in the chat, right? So you can drop feedbacks if you want to learn more about software engineering. You want to, and remember, you can actually check out my profile if you want to learn more on software engineering. At Better Copper, I'm sure there are a lot of plans on ground with materials. They have micro degrees, right? If you want to get into DevOps, if you want to get into cloud engineering, Python engineering, they have several roadmaps and courses that you can take. And yeah, they also have a lot of crash courses. Yeah, so they have a lot of crash courses that you can use. Right, let's check out the Betacop website. So there are so many crash courses that are always coming up, for people to learn and practice software engineering and also use modern tools. There are some crash courses, I believe, on AI, and I was informed that some new crash courses will be launched, so you can always check them out, right, as they keep coming out. So thank you. Thanks for joining. I'm still waiting for the questions. If you have any question, feel free to drop those questions in the chats. Feel free to drop those questions in the chat. All right. Feel free to drop those questions in the chat. And yeah, so you also have access to the slide. Go through the slide. Ask your questions on the Better Copper Discord server. You can join the Discord server. It's quite simple, and the amazing fact about being on a Discord server is that you can easily get access to people that can help you. All right. So let me go ahead and share this with you. You can have access to people that can assist you through your journey. So check out. I think that should be discord.bettercopper.com, right? So that will basically take you to the Better Copper community. So let me drop that. Um, Oh yeah, yeah. So it's okay. So Joseph is saying, given the experience that you have, sir, do you have a resource that deals with Django in particular? Okay, and go straight to the point for a learner like myself. I mean, we can arrange for that. If you're on the Better Copper server, Discord server, just drop that question for me, and I would try to get something for you. I think in the previous classes we have covered Fast API, Flask, and yeah. So I would. Join the server. This is the URL to join the server. So that should be, I think, Discord, bettercopper.com. So join the server, tag me on the server, drop a question. I would see it and I would respond. Okay. I do have a lot of materials, but I can't really search through those materials right now. And I can also get like vital links and videos. And if we have any training where we also will be covering Django, I will let you know. All right. So go ahead and join the server. You have access to me. You can ask questions on the server, and I would respond. Okay, so I think we also have the sorry, we have the I think this is the feedback form. Yeah, probably this is the feedback form. I'm not very sure. Oh, okay. um was that you? Who is on the stage with me? I think that is yeah, so I think that was a different link. Hi Amaka, can you hear me?
Hi, Mav. Yes, I can hear you clearly.
Oh, okay, all right, thank you. Okay, so I think that will be all. So do have a wonderful time, and you can join the server, and I'll see you next time. Bye, guys.
Goodbye, Mav. Thank you so much.